Welcome to the DOSS podcast series, where we explore how the modules of the IoT supply trust chain architecture improve the security and the reliability of IoT operations. Today, we are discussing the component tester. We are having with us Martin Schneider, Head of Testing at Fraunhofer Focus in Berlin, Germany. Martin, could you please explain why testing individual software and hardware components is so important for the IoT systems in today's architectures?
Yeah, thank you for the introduction. So modern IoT systems are usually built from dozens or often hundreds of different components that can be developed by different manufacturers and suppliers and are integrated into a single IoT system. And the main problem is that all of these components may have their own vulnerabilities that put the security of the overall system at risk. Because even if you design the entire system carefully with respect to security, the vulnerability of each of the components may enable a way for an attacker to compromise the entire system. And that is why it's important to start security testing early, already at the component level, addressing vulnerabilities as early as possible in the development process in order to ensure that the entire system is secure and to implement a security by design philosophy that would allow you to build security into the system during the entire development process and not trying to add it at the end, because this usually fails. Adding security at the end is not a viable option, and that is why you should include already each and every component in the security testing process.
Many organizations do already perform security testing. What makes the DOSS component tester different from these existing solutions?
Yeah, it's absolutely true that many organizations already perform some kind of security testing, but the main problem is that they often employ only a single tool or a single approach. And the main advantage of the component tester is that it integrates and combines different testing approaches. So some organizations perform, for instance, static analysis, analyzing the source code to identify certain kinds of vulnerabilities. Others employ, for instance, fuzz testing or other dynamic security testing approaches. But the advantage of the component tester is that it not only combines the different testing methods, it also integrates them, which allows to coordinate their execution in a way that makes the overall approach more efficient and more precise. And it also provides the resulting evidence that you would need for the compliance with the Cyber Resilience Act, so that you have already reports early that demonstrate which kind of security testing you have applied and that was done in an efficient way.
So, Martin, we heard that the platform combines several technologies such as static analysis, dynamic testing, firmware fuzzing, and also SBOM analysis. Why is it important that you include all these approaches?
So the reason is that all these methods are valid, but not all of them can identify each kind of vulnerability, but that would be necessary. And on the other hand, it also allows you to perform a more comprehensive check when you apply and integrate all these methods. Static analysis can find, for instance, vulnerabilities in the code while you are writing it. Dynamic testing can find vulnerabilities that are shown only during execution of the software. But if you apply only a single method, you cannot find all these vulnerabilities. And then there's a third part that is the firmware fuzzing part, and that is the part that is often neglected in security testing. So the low-level software of an IoT device also contains vulnerabilities. And if you perform only the security testing of the application level code, then you will miss that kind of vulnerabilities, and they are often attacked and exploited by attackers. So it's also important to check the firmware as well for the vulnerabilities that might be there. And then there is the last component that you said, that is the SBOM analysis. So the SBOM is a single bill of materials, so that is some kind of list of components that are delivered with your software, with your system. So it includes all the different components and libraries you have integrated in the IoT device, and that is actually a requirement from the Cyber Resilience Act that you need to provide and generate such a list. And on the other hand, as I said in the beginning, all these components that are listed in the SBOM may contain their own vulnerabilities. So they increase your attack surface, they bring new vulnerabilities, and if you're not aware of them, you may deliver an unsecure product. So analyzing the SBOM itself is also very important to ensure a secure product.
So what are the main benefits for developers or manufacturers using the component tester during product development phase?
So the biggest advantage, I would say, for developers is that they get a more comprehensive security testing approach and feedback from the component tester very early during the development process, so they can address vulnerabilities when they arise. And on the other hand, the component tester is an integrated module of the DOSS supply trust chain that does not require that developers are familiar with all the different tools and approaches, because the component tester would configure them and execute them. So the required skills are also less, so the developer can focus more on the code and less on the testing.
And then how do these testing results support the other DOSS modules and contribute to the secure by design development process?
Yeah, so the component tester is one part of the broader DOSS ecosystem, that is the supply trust chain, which contains a very important part, that is a so-called device security passport. It contains all the relevant information about the IoT device and includes also all the results that the component tester generates. So each vulnerability, each test report, and also the SBOM is stored or linked in the device security passport, so that everyone that is a stakeholder of the IoT device that is described by the DSP has access to all this critical information, which allows, on the one hand, the communication between stakeholders across the supply chain. For instance, if the manufacturer identifies the vulnerabilities, he can easily communicate to all the stakeholders and inform them early, as required by the Cyber Resilience Act, for instance, about these vulnerabilities. On the other hand, also, if some vulnerabilities are observed in deployed products, then they can also provide such information through the device security passport to the manufacturer, so that the manufacturer can also early fix them. So in that way, the component tester is one part of the ecosystem that performs an important step in developing and deploying secure products and integrates with the other approaches and modules from the supply trust chain, which in the end also would facilitate certification of the products that might be necessary depending on the type of the product for the CRA compliance.
And looking ahead, how do you see integrated component testing changing the way secure IoT products are developed?
Yeah, so what I think is that the component tester would allow more organizations and more developers to perform continuous security testing. So what is often done is that you try to perform security testing later in the development process, which may result in detecting vulnerabilities very late, that raises higher costs to identify and fix them. And with the component tester, developers are able to perform continuous security testing throughout the entire product to also be compliant with the Cyber Resilience Act, but also to deploy products that are actually secure with lower cost that will be a competitive advantage for each manufacturer. And as I said, it will also provide the compliance with the Cyber Resilience Act, because it requires regular and effective security tests. And this is what the component tester will actually provide to the developers and to the manufacturers of IoT devices.
Martin, thank you very much for this discussion about the DOSS component tester.
Thank you, Anna.